Welcome back to this new lecture, and in this lecture we talk about more advanced topic of NumPy. So you get more intuition about NumPy, that what actually NumPy is. So NumPy leverage the power of different implementation of arrays. So for example, here's a function of NumPy called zeros. So what this function do is NumPy dot zeros and giving the shape of 2 comma 3. So sorry. Uh, in So what this function do is it's created 2 comma 3 dimension data, and the data inside is all zeros. So the zeros function takes a shape of the your array, and it's fill your array with the zeros. So this is one function in NumPy to fill your whole array with zero. Now this sometimes help in machine learning when you're doing a one hot encoding vectors. So we learn this thing about in upcoming sections and lectures. So this is one of the functionality called zeros. Now similarly we have another functionality called ones. So as you guess, it filled all the values with ones. So when you print ones data, we get all ones. So similar as that. Now we have one more functionality called uh, numpy.fulls. So what this do is, for example, let's define the same shape. So 3 comma, let's define 4 here, and now define 5 here. So what this do is it's filled all the data of our numpy array with the 5 or the number we specify here. So it's created 2 comma 4 dimension matrix or data and filled all the data with this same 5 value. So full means full all the data with us same value. Now we have another function or some random to create a random random matrix of a specific size. So create a random numpy dot random dot rand and random number. So let's create a 4 by 5 dimension data or matrix array, and when you print that we get a random value. So as you can see that the minus 0.8. So this is just a random, these all are just random values. We generally create this to initialize our neural network or weights of our neural networks. So that's why we use this random numbers here. Now similarly with random we have another function called rand int, in which we give our lower bound. So for example 4, and upper bound for example 10, and the shape of our data. So 1 comma 4. So what this thing do is it's take number from 4 to 10, means it take number between 4 and 10, and create a 2 comma 4 dimension data that all filled with number that is ranging between 4 to 10. So let's create rand in, and when we print this we get our 2 comma 4 dimension data, in which each element or each element of our array is belong to a range between 4 to 10. So this is lower range and this is upper range or upper bound. So that's how we implement this random data. Now there's one more function. I generally, there is a lot of function in NumPy, but I explaining some of the most important function. So the function is numpy.identity. So as you know from high school mathematics, what is identity matrix? Generally that all the matrix, all the numbers or elements of the matrix is zeroed except the diagonal. So let's see that. We specify 6 here. So 6 by 6 matrix automatically created, and the diagonals is filled with 0, and except diagonal we get all value filled with 0. So this in diagonal we have ones and all is 0. Now this is identity matrix. We also use this identity matrix in deep learning. So that's why I mention in this lecture. I generally mentioning all the function that are required in deep learning space. So these are some of the functions. Now we have some little more function. So first of all, we have a repeat function. So what this repeat function do is, for example, we create a numpy array of 3, 4, 5. Now we have this numpy array as in a single dimension array. So you are familiar with that, I know. So single dimension array. So how can we repeat this array? For example, if we want to repeat this array 3 times, what can we do that? So how can we do that? So to do that, so there is a function in PyTorch with the help of this we can repeat our array. So for example, here is our let's say we have an array np dot array number of 2 comma 3. Sorry, np dot 5 again typo that, random dot rand number, and we have a 2 row and 3 column dimension data. Now if we want to repeat this data, what we need to do is just use numpy dot repeat, and so like this, repeat, and specify the array which is a in our case, and specify how many times you want to repeat. So I want to repeat 4 times, so numpy, and in which axis you want to repeat. So row is generally 0 axis and column is generally 1 axis. So this is 0th axis, and this is 1 axis. So I want to repeat alongside with 0th axis. So let's run this. So as you can see that each element, each row of our original array is repeated 4 times. So 1 2 3 4, and same with this second row, 1 2 3 4. That's so this is how repetition works. So for example, I repeat 2 times only, so our each row is repeated in 2 times. Now if specify axis 1, it's repeat along column dimension. So for example, these are our original number, and these repeated alongside our column. So that's how repetition work in rows and columns. You can check out this thing, that how these things are working. You can also practice that because it is also very important. Now one more very sufficient and important thing. When we define our numpy array, so like this, numpy dot array 5 6 7, and let's print this array. So we have this array. Okay, now if we want to copy the array and use this simple copying mechanism by assigning the variable and copying this data of this original to this b variable, and when we print our b variable, we get similar a 5 6 7. Now if we do some manipulation in b, for example, if we change element of last element to 10, and if we print b, so as you know that b is changed, so we get 5 6 10, but a also changed. So when you print original, this were original. So when you print original are also changed, so 10, because when you assigning something like that, it's only giving the reference to this original value. Means if you do something in this b, this is also affected in this original data. So this is not a copy of this original data, this is just a reference of address of this original data, and what we change in our b this variable is affected in our original array or original data. So to tackle this, what we need to do is just use this copy function here, and when we use this copy function, anything that we do in b doesn't affect our original tensor. So let's specify the original tensor again, specify b here, and by copying that, so it's create a new copy in the b variable, and when we manipulate b, and so b is manipulated, let's check that b is manipulated, and when we print our original array, that is not manipulated at all. So because we create a new copy of that our original array in our b variable or b object. So that's how copy function work, and that's how all the most famous and used case function works in NumPy. So practice all this, and meet you in the next lecture. Until then, bye bye and enjoy learning.